Hi, my name is John Kinsey. I'm a wildlife research biologist for Texas Parks and Wildlife Department, housed on the Kerr Wildlife Management area, and I'm also a PhD student at the University of Texas at San Antonio. Before we get started, I'd like to go ahead and thank the contributors to this project so that I don't forget to do it at the end. APHIS, Wildlife Services, I'm going to start with those guys because when you're using live pigs as your research subjects, a lot of times it's very difficult to stay stocked. And those guys are the boots on the ground, and they're providing us with a lot of our research subjects. We definitely couldn't be doing this without those guys. Texas Parks and Wildlife, obviously, Animal Control Technologies in Australia is the manufacturer of the bait, and UTSA, where I'm pursuing my PhD. So I've been on this project for approximately 6 years. And a lot of my job is public outreach and education, talking to the general public about pigs. It's not a secret that we're involved with the testing of some oral toxicants to control pigs. So inevitably, that comes up in the questions that I get. And we have discussions, and one of the questions that consistently was asked of me across the entire state was, how much bait is on the ground? Because pigs don't eat clean. We know that there's going to be some spillage. And I never had an answer to that to quantify. We were never able to quantify that amount of bait. So the study design for this project was moving forward whenever our collaboration went into the field with Hoggone under an EUP permit from the EPA in 2018. We learned in that study that our feeder was 100% effective, but pigs do in fact spill bait, and non-targets do have access to that spilled bait. So in some of our previous research and observations of videos and photographs throughout the past decade or so, we noticed that the way that we present bait in the bait box to pigs may impact the amount of bait that's on the ground after a feeding event. Essentially, the crumbled method that we used in that EUP study resulted in ununiform distribution and ununiform sizes of bait in the bait box. And the pigs were able to grab a mouthful of bait, and due to the competition at the bait box, they would walk several meters away from the bait box, masticate, and during the mastication process, bait would fall to the ground. We noticed that if we presented the bait to pigs in the trays that it's originally packaged in and shipped in, the bait is very tightly compacted. And the pigs use their bottom incisors very similar to an ice cream scoop and roll bait up into their mouth. And it limits the amount of bait that they can get in their mouth at one time. When you limit the amount of bait that's in their mouth, you limit the amount of bait that may fall out during mastication. So it got us to thinking, on top of some of the other mitigation methods that we were implementing, does the way that we present bait in our bait boxes impact the amount of bait that's on the ground post-feed? So in order to do this, we conducted a two-phase study in our feral pig research facility on the Kerr Wildlife Management area. We've got 3 half-acre pens. We ran 4 trials in phase 1, and in each one of those trials, each pen received a different treatment. We had 7 pigs per pen. We followed a pig-informed approach to acclimating those pigs to the bait boxes, but we did it in a little bit accelerated manner. And we never fully closed the bait boxes for the study. We allowed them to remain open approximately 2 inches. At that 2-inch level, the pigs still had to utilize their snout to open the box, so it functioned as if it were closed, and the weight of the lid was still on their head like it would be if the lid was closed. And then lastly, we constructed 21 meter by 21 meter crushed limestone pads in each of the pens. We did that because the bait is a very dark color, almost black, and the contrast of the light ground and the black bait might allow for easier or better detection from observers. So just real quickly, this is what the treatments look like. The crumbled treatment here you can see is not uniform in size and not uniform in distribution. This is what it looks like when it's shipped to us. It's shipped in these trays. It's a plastic tray I liken it to a TV dinner tray. For this method, all you do is you rip the plastic covering off the tray, you sit in the bottom of the feeder, and then you put the divider on top of the trays and secure it with screws so that the trays cannot be removed from the bait box. And then to go along with the idea of if you limit the amount of bait that they get in their mouth at one time, you limit the amount of spillage. We decided that we would extrude Hoggone through DeWalt electric caulk guns, and which resulted in these little worm segments, is what we call them. Again, just limit the amount of bait that you can get in, that the pigs can get in their mouth at one time. After a toxic deployment, the morning after, we conducted dependent double observer surveys. And simply what we did is we had 2 observers walk in a line spaced approximately 3 meters apart from each other. The first observer would mark identified spilled bait events with a uniquely numbered tag recorded on the data sheet. Observer 2 followed approximately 3 meters behind, and they only recorded bait drop bait events that observer 1 missed. So once all the transects were walked and all the observations were identified, we went back and measured the distance in degrees from the center of the bait box for each drop bait event. And then we collected the drop bait and recorded mass of each event. On top of that, we know we're not perfect, and we're talking about very small pieces of bait. We did an observer error survey where we followed the exact same methods above as those double observer surveys, but with known quantities of bait. We had a third team member distribute known quantities of bait across the pad. Then each individual team that performed double observer surveys for the drop bait conducted 3 double observer surveys to get an average of our error for each team. And then on top of that, we conducted an exhaustive search within the first 45.72 centimeters, or approximately 18 inches of the bait box. We did that because the distribution of bait around the immediate area of the bait box was such that we couldn't identify individual drop bait events. So we divided that area in half. We had an east side of the box and a west side of the box, and we considered that one event. So as a result of those spilled bait surveys, the error surveys, we found that we were roughly missing 26% of the bait that was on the ground. And then the median bait mass per event, not the event itself, but the pieces of bait within that event. It wasn't very often that an event was just one piece. It was several pieces of bait scattered across the ground within an 18-inch circle. The median size of individual pieces of bait was 0.31 grams for the crumbled, 0.07 for extruded, and 0.17 grams for trace. So we're talking about very, very small pieces of bait. You can see here on the size chart on this slide. And this slide is a representation of one replicate using trace. You can see the diagram over there shows the distance and the degrees from the bait box. And then the size of the circles represents the mass of the bait. In this particular trial, 75% of the bait that we observed, those events were less than 0.25 grams. Then when you're looking at the difference of the amount of bait that's on the ground post-feeding, we reduced the spillage by 66% just by moving away from the crumbled presentation method to trays. The extruded was also significantly reduced when compared to trays, but due to some logistics and the fact that, and the proximity of the bait to the bait box, as shown in this slide, we went with trays moving forward because we should be able to mitigate that 50% of spillage there within the 18 inches of that bait box very easily. So moving forward in phase 2, we strictly used trays. We followed the exact same methods as we did in phase 1. for trials, but in this instance, we only used trays across all 3 pins. So it resulted in 12 more replicates and ended up giving me 16 replicates for the entire project. So this is just summary statistics of all 16 replicates using trays. You can see quite a bit of difference between our minimum and our maximum there. And that's indicative by that high standard deviation. So I think it's very important to pay attention to the median here and not necessarily the mean in these situations, because you see we end up having, like you can tell in this chart, some major outliers out here. Of all 16 trials and of all 531 observations of drop bait, 73.6% of that drop bait fell within 3 meters of the bait box. There was only one major outlier there, and it was one event that happened one time, one night, one trial. It happened to be greater than 13 meters away from the bait box, and that one piece of bait weighed greater than 30 grams. So what does this mean when we're talking about how much sodium nitrite is actually out there after a feeding event? And we're going to go with worst case scenario here. I took that maximum amount of bait that we found post feeding, and assuming that we can mitigate that 50% within that 18 inches, I reduced it by 50%. So that leaves us with 16.12 grams of Hoggone spilled after a feeding event. Then we assume an even mixture of sodium nitrite and know that the Hoggone is 5% loaded with sodium nitrite. And we see that per 7 pigs, there are 860 milligrams of sodium nitrite on the ground post-feeding event. So what that means per pig is 115 milligrams of sodium nitrite per pig. How does that relate to some of the species that you see out there that may have access to this bait? You can see the results of this study indicate that we have very, very low risk to non-target species outside of that zebrafinch information right there. And that's where we're focusing our efforts on at the moment, further understanding what that risk is for avian species and determining how we can better mitigate that risk moving forward. So in conclusion, we see most definitely that feeder loading impacts the amount of spill after a feeding event. And having a better understanding of how much bait is on the ground and the proximity of that bait to the feeder will allow us to better mitigate risk to non-target species. You see, as I said, approximately 75% of the bait across all trials fell within 3 meters of the bait box. I believe we can mitigate that, but elimination of spill is not likely. So we need to continue to understand the risk of non-target species moving forward. So the question was brought up if you were at the 2018 Wild Pig Conference, what is acceptable risk? And it was evident at that meeting in that room that if you had 100 people in a room and you asked them what acceptable non-target risk was, you would get 100 different answers. So it's not an easy subject that we're going to have to start talking about, but it's something that we really need to start having a conversation. And with that, I look forward to seeing those questions. And thank you, Jessica, for setting all this up. My email address and phone number are on this slide. Please don't hesitate to contact me with any questions. Thank you.